Assalamualaikum and hi. Today we are excited to present our project entitled that Sustainable Concrete with Eggshell Powder as a Partial Fine Aggregate Replacement. And this project is part of our ECS246 as a coursework, and it reflects our effort to explore innovative, cost-effective and eco-friendly alternative in concrete design. And now I will introduce my group members. First is Muhammad Hafiz bin Abdul Muttalib. Second is Muhammad Haris Muzaffar bin Muhammad Haizar. And next Aminur Afiq bin Ramzi. And the last one is Muhammad Faris Hakim bin Muhammad Faizal. As you can see on the slide, this is a presentation outline of this project.
Sustainable construction practice have become more stand out in recent years as developing environmental concerns and efficient use of resources. One of the innovative methods presented in this study is the use of waste material, specifically eggshell powder, as a partial replacement of fine aggregates in concrete production. Eggshells are typically disposed of in landfills as food materials. The eggshells included in this study are mainly calcium carbonate, which provides an interesting alternative materials for sustainability use. The objective of this study is to attempt to formulate a concrete mix design of grade 30 concrete that utilizes varying percentage of eggshell powder, 0% control, 5% and 10%. The project intends to assess the performance, cost and environmental benefits with using eggshell powder in concrete. This study concerns a viable concrete mix design of using eggshell powder to indicate the global agenda to undertake the challenge outlined in the United Nations Sustainable Development Goals (SDG) of quality education (SDG 4) and industry innovation and infrastructure (SDG 9). The result of this project will indicate the feasibility of utilizing an eggshell concrete composite in the construction site industry of Malaysia as a cost-effective and environmentally alternative in concrete. By doing the research, we can see that one of the main benefits of using eggshell powder as a sustainable construction material is that it can reduce the need for more traditional non-renewable materials such as cement.
So on this slide, focus on the methodology. 2.1 material use. For the material use, we use water. Water cement ratio is obviously used 0.53 and it can be controlled with workability. Second is eggshell powder as a fine aggregate. It can be well aggregated and increase the workability. Next, gravel as a coarse aggregate. It can be increased the strength maximum aggregate obviously 20 mm. And the last one is the cement, and we commonly use of the ordinary Portland cement, which is OPC, and it can be react with water. In this section, we found that the effect and changes that occurs on eggshell powder as a waste material to replace for fine aggregate in the concrete. So from the research, the eggshell was produced according to the correct procedure, including by collecting, cleaning, drying and grinding the eggshell waste into a fine powder and past the size of 75 sieves and making for concrete mix, which is 0%, 5% and 10% eggshell by weight. Next, 2.2 mix design for sustainable concrete with eggshell powder. So as you can see on the slide, we test on 0%, 5% and 10% of ESP. So by doing the research, we can see that for me 0%, 5% and 10% of eggshell powder, water cement ratio we get is 0.53, 0.54 and 0.52 respectively by calculation. And from the research, it also presenting the same thing. Next, 2.3 procedure for concrete preparation. For this slide, for the stage 1, we do a mixing. First, we need to dry eggshell waste into the fine powder that pass the sieve of 75 sieve. Also, we need to make sure that the dry mix of ESP, cement and sand for 2 minutes, and we add the water to another 2 minutes. And then we do the process casting. For this part, we will 150 ml cube molds, and then we compare it by using the table vibrator. Next is curing. After 24 hours, cure sample in water at 27 Celsius for 28 days. And the last one is the procedure is enhanced current by research, that particularly in testing ESP viability by follow the correct standard procedure. Next, 2.4 methodology classification. This project was adapted from Kao and Singh 2018, Das and Peter 223 and Rahman at Leong 220. And grade of character strength of this project is 30 are used for realistic structural relevance, and eggshell powder also less than 75 sieve that encourage the long-term strength and durability. And all of this is aligned with the SDG 4, which is quality education, SDG 9 industrial innovation and infrastructure, SDG 12 responsible consumption and production.
4.4 findings. Based on the research, we found that the additional of an admixture in the form of eggshell powder can be effectively for enhanced mechanical properties, particularly compression strength. 4.1 Study of the eggshell powder as particle replacement with cement in concrete from IJARESM. In this test, the 5% ESP replacement achieved a compressive stress of 43.7 megapascal at 28 days compared, marking the higher recorded strength and indicating optimal performance at a 5% replacement level. Finding 2. Evaluating the use of eggshell powder and sawdust ash as cement replacement in sustainable concrete development from Journal of Sustainable Construction, Material and Technologies. In this test, the 0% ESP replacement achieved a compressive strength of 26.1 megapascal at 28 days, compared to second higher compressive strength when using 4% ESP. Marking 0% ESP is higher recorded strength and indicating optimal performance at a lower replacement level. Finding 3. Experimental investigation of eggshell powder as partial replacement with cement in concern from Turkish Journal of Computer and Mathematics Education. The compressive strength increases with the addition of up to 10% ESP, peaking at 28.5 megapascal at 28 days. This is higher than the control mix 26.5 MPa per ounce. 10% ESP, the compressive strength decrease, indicating the 10% is the optimal replacement level. Comparison and conclusion. Adding eggshell powder to concrete can increase compressive strength when used in the right amount. In first study, replacing 10% of cement with eggshell powder gave the best result, with a 7.547% increase in compressive strength compared to normal concrete. Other study also show good result with 5% or 10% eggshell powder. This means that eggshell powder can improve concrete strength at certain percentage.
To begin with, we find that using eggshell powder ESP as a partial replacement for cement can make concrete more sustainable and affordable by the study from Eggshell et al. 2022, when 5% to 15% of ESP was added, especially the finer 100 micrometer type. We determined that the concrete produced less carbon dioxide and still maintained good strength. Hence, this means the concrete was not only strong but also better for the environment. Furthermore, in terms of cost for this material, we understood that ESP helped reduce the total cost of making concrete. It was also cheaper to produce each unit of strength, that is MPa, making it a smart choice for both the environment and the budget. For countries like Malaysia, where sustainable and cost-effective construction is important, ESP could be a practical solution for this thing. In conclusion, by doing research and background study for this assignment, we found that using eggshell powder ESP as a partial replacement for cement in concrete is a smart and sustainable solution. Studies show that replacing 10% to 15% of cement with ESP can maintain or even improve concrete strength while reducing harmful carbon emissions by up to 11.6%. Moreover, this helps lower the environmental impact of construction and makes use of waste materials that would otherwise be thrown away. Lastly, in a country like Malaysia, where eggshell waste is widely available, this innovation can reduce construction costs and support greener building practices. It also prepares future engineers to think creatively and responsibly about materials. This study also shows us that by turning waste into a useful resource, this could support both environmental goals and practical engineering needs for future use where materials could be limited.
Now let's talk about summary objectives and sustainable development SDG alignment. First and foremost, summary. Eggshell powder ESP at 10% to 15% replacement maintains the compressive strength in grade 30 concrete. By the way, it proposed environmentally and structurally viable for lightweight construction applications. Next is objectives. We successfully analyzed the economic and environmental impact by comparing ESP mixes with conventional concrete. We can provide evidence support for ESP as a feasible alternative, especially in sustainable construction. Lastly, Sustainable Development Goal SDG alignment. It follows SDG 4, Quality Education, SDG 9, Industry Innovation and Infrastructure, and SDG 12, Responsible Consumption and Production.
As we can see on this slide, this is our reference why do this project.